Hello, welcome to Chapter 9, Homework Questions 33 through 40. Question 33. In the diagram at the right, line segment DE is a mid-segment to triangle ABC. So if it's a mid-segment, then we know that AD and DB are congruent, and we know that AE and EC are congruent. If the area of triangle ABC is 96 square units, what is the area of ADE? Explain how you know. So, since we know that it is a mid-segment, we know that this full length of AB, D cuts that in half. So that triangle is going to be half of what the other triangle is. So the linear scale factor would be 0.5. And since we're looking at area, if we square 0.5, that's 0.25. And so triangle ABC is 96 square units. We're looking for triangle ADE. It's going to get smaller, so we're going to take 96 times 0.25, and that will give us 24 units squared for the area of triangle ADE. Question 34. A regular hexagonal prism has a volume of 2,546.13 centimeters cubed, and the base has an edge length of 14 centimeters. Find the height and surface area of the prism. All right, let's see. The volume, we have that. The base has an edge length of 14, so we can set up our one of 6 triangles of the hexagon on the base there, and since it's 14, when we split this in half, this would be 7. And this would be 7, and since it's hexagonal, if you take 360 and divide by 60, or 360 divided by 6 and get 60, we know these are 30, 60, 90 triangles, or the triangle itself is a equilateral triangle, so this side length is 7 as well. Or not 7, sorry, 14. And then the height would be 7 square roots of 3 using our special right triangles. So to find the area of the base of the volume, we are looking for 1/2 the base, which is 14, times the height, 7 square root of 3. And that's just for this triangle, but then we'll have to multiply it by 6. So 7 times 7 would be 49. So the area of one triangle is 49 square roots of 3. And I need 6 of them, so 6 times 49 times the square root of 3 would be equal to 294 square roots of 3. That's the exact area. So this is the area of the base of the hexagonal prism. Since we know what the volume is, then if we know the area of the base and we divide the volume divided by the base, that will give us the height. Think about when we find the volume. We want the area of the base, we want to multiply it by the height. So we're just going to work backwards. So we'll take the volume, 2,546.13, divide that by the base we just found, 294 times the square root of 3. And let's see what it gives us for the height. And so that will be 5 centimeters. So we know that the height now, so this is equal to the height of the prism. So we know the height is 5 centimeters, and the surface area of the prism we need to calculate. So we have the area of the base, which is right here. So there's 2 of those, and then there are 6 sides of the hexagonal prism, so you have 14 by the height, which is 5. So let's put all this stuff together for the surface area. So surface area is equal to, we have 2 bases, so 2 times 294 times the square root of 3, plus we have 6 sides with height of 5 and what was the edge base was, or the edge length was 14. So 14 times 5, and then there are 6 of them. So therefore I got a surface area equal to 1,438.4 centimeters squared. So surface area Found that, and the height we found as well. Question 35. Are triangle EHF and FGE congruent? If so, explain how you know. If not, explain why not. I feel like we've done this problem a couple of times now. EHF, so we have H is congruent to G. We also have that angle GEF is congruent to HFE. So those are congruent. And then we also know that this side is congruent to itself by the reflexive property. So therefore, if you follow here, we got angle, side. Same thing here, angle, side. So yes, they are congruent by angle, side congruency. Question 36. A sandwich shop delivers lunches by bicycle to nearby office buildings. Unfortunately, sometimes the delivery is made later than promised. A delay can occur either because food preparation took too long or because the bicycle rider got lost. Last month, the food preparation took too long or the rider got lost 7% of the time. During the same month, the food preparation took longer than expected 11 times and the bicycle rider got lost 4 times. There are 200 deliveries made during the month. For a randomly selected delivery last month, find the probability that both the food preparation took too long and the rider got lost. All right, so a lot going on there. Let's read through this again and maybe highlight some important information. So the first part, unfortunately, sometimes delivery is made later than promised. A delay can occur either because there's food preparation took too long or because the bicycle rider got lost. So those are the 2 reasons. Last month, the food preparation took too long or the rider got lost 7% of the time. During the same month, the food preparation took longer than expected 11 times, so it took longer 11 times, and the bicycle rider got lost 4 times. There were 200 deliveries made during that month. All right, so we have a lot going on here. The food preparation took longer than expected 11 times, so that would be 11 out of 200. So 11 out of 200, this represents that it took too long. And the bike rider got lost 4 out of 200 times. So that would be 15 out of 200. Now, right up here it says 7% of the time last month the food preparation took too long or the rider got lost. So it could have happened both. The rider could have got lost and the food preparation took too long. So if you take 15 over 200 right now, you're going to get a percentage of 7.5%, which is not 7% of the time. And the reason that is because it could have happened both times. So one of these that took longer could have also gotten lost, and they're mixed in there. So we actually have to subtract out the probability that both of them occurred, that the food preparation took long, and also that the bike rider got lost. And then that should equal the 7%, or we'll write it as a decimal, 0.07. And so now we need to solve for that piece in terms of the probability. So to solve this, we can combine the 11 200s plus 4 over 200 to be 15 over 200. I'm going to add the probability to the other side and subtract the 0.07, so I'm going to switch some places here, but then this is the probability that it took too long and the bike rider got lost. So 15 over 200, I guess, minus 0.07 is going to give us 0.005 as the probability that they got that the food preparation took too long and the bike rider got lost, which is 0.5%. So 0.5% is the probability that both the food preparation took too long and the rider got lost. Which for this 0.5% would be 1 person for every 200. So there was only one time out of that 200 that they got lost and that the food preparation took too long. Question 37. Remember that the absolute value of a number is its positive value. For example, the absolute value of -5 is equal to 5, and the absolute value of 5 is equal to 5. Use this understanding to solve the equations below. If possible, if there is no solution, explain how you know. So typically kind of cover this up and ask, what number can I plug in there? And I could plug in -6 or 6, so therefore whatever's underneath there in this case is x equals -6 and x equals 6. And those are our two answers. You can also write them as a set, but you got to use the curly brackets to do that. This absolute value, can I plug a number in here where when I take the absolute value I get a -2? And the answer to that is no. There's no number that when you take the absolute value is going to give you a negative answer. So there is no solution for part B. And then for C, once again, if I kind of cover this up, what numbers can I replace here? Well, I could replace it with a -10 or a 10, and both of those would give me the absolute value is equal to 10. So what's underneath here? We're going to set equal to -10 and 10. So x plus 7 could equal -10. X plus 7 could equal a positive 10. So if I subtract 7 to both sides, we get x equals -17. Subtract 7, and x is equal to 3. So the solutions for part C would be -17 and 3. Question 38. Cindy's cylindrical paint bucket has a diameter of 12 inches and a height of 14.5 inches. If 1 gallon is approximately 231 inches cubed, how many gallons does her paint bucket hold? So we have our paint bucket here, and the diameter is 12 inches. So across here is 12 inches, which means the radius is 6 inches. And we have a height of 14.5 inches. And we're looking at volume. So we want to find the area of the base, and the area of the base is a circle, so that's pi r squared. So r is 6, so that would be 36 pi. So that's the area of the base. And then once again, think of how many layers that you have that you need to add up, and that's the 14.5. So 36 pi times 14.5 will give you a volume of approximately 1,639.9, and that would be in inches cubed. So that's what the volume is. If 1 gallon is approximately 231, then we should be able to take the volume of this paint bucket and divide by 231 approximately to figure out how many gallons it holds. And so that is approximately, really, about 7 gallons of paint for Cindy's paint bucket. Question 39. Write the equation of an exponential function that passes through the points 0, 32 and 3, 4. So an exponential equation, we need two things. We need the starting value, which is given to us right here. There's the y-intercept. And we need to figure out how much it is growing, or in this case, it looks like it is decaying. So I like to set up a table for these, as long as the numbers aren't too far apart, and just kind of look at where we're at. So we're at 0, 32, 1, 2, 3 goes to 4, and so then, I know that I need to multiply 32 by b, or the multiplier, 3 times. So that's 32 times b cubed is going to equal 4. And then I can divide by 32, and that would reduce to 1/8. And then I can take the cube root of both sides to get b by itself. And the cube root of 1/8, if you take the cube root of 1, that's 1, and the cube root of 8 is 2. So b has a multiplier of 1/2. And so I know the starting value is 32, so we can write the equation. Y is equal to 32 is my initial, my multiplier is 1/2, and then that gets raised to the power of x, because 1/2 is the one that you keep multiplying. So for example, if b is 1/2, 32 times 1/2 is 16. 16 times 1/2 is 8. 8 times 1/2 is 4. And so there you go. There's your equation. You need, once again, you need how it's growing, that multiplier, and then where it's starting. Question 40. A cork in the shape of a cylinder has a radius of 2 centimeters and a height of 5 centimeters and weighs 2.5 grams. What is the volume of the cork? All right, so volume, it's cylinder, so we need the base. That's a circle, so pi r squared. The radius is 2. So we know that the area of the base is 4 pi. So once again, this is the area of the base of the cylinder. And then we need the height, which is 5. So the volume is equal to 4 pi times those 5 layers once again, or that height as 5 centimeters. And so therefore the volume is 20 pi centimeters cubed. And we can also approximate that. So the volume approximately is 62.83 centimeters cubed. So that's for part A. Part B, what is the cork's density in grams per cubic centimeter? That is, how many grams of cork are there per cubic centimeter? All right, so how many grams of cork are there per cubic? So we want grams over cubic centimeters. So we have 2.5 grams, and there are 62.83 cubic centimeters. So if you divide 2.5 divided by 62.83, that'll give you approximately 0.04 grams per cubic centimeter. So once again, pay attention to the labels. It's the grams per and then cubic centimeter at the end. So that's why we would go grams over the cubic centimeter.